When we look at molecules, there is an incredible range of size from the teeny tiny water molecule that is one oxygen and two hydrogen atoms to DNA, which is just really, really large. And here's a section, there's a graphic here of a section of DNA, and this is just a section of DNA compared to water. You can see how much more massive DNA is. Regardless of the size of the molecule, covalent bonding follows the same principles. And while we're looking at this graphic, I want to point out that the 6 biologically important atoms or elements that we find in biological molecules are so common that they have specific colors in these molecular models. Hydrogen is always white, carbon is always black, nitrogen is always blue, oxygen is red, and phosphorus depends on the book, but for our book, it's going to be orange. Now, when we look at the electrons of an atom that engage in bonding, they are always going to come from the valence electrons. So it's super important for us to be able to determine how many valence electron a given atom has. And we learned how to do that in Chapter 2 by looking at the group number that a given element is in. So let's just quickly review the 6 important elements in biological molecules. Carbon is in family 4A, so it has 4 valence electrons. Nitrogen and phosphorus are in family 5A, so they both have 5 valence electrons. Oxygen and sulfur are in family 6A, so they have 6 valence electrons, and hydrogen in group 1A has 1 valence electron.